Right, that is something interesting. You look at this plot right here. Okay, if you can see my screen, look at this plot right here. All right, and then you look at the definition of the functions here. 1 over x minus 1. Okay, let me ask you this. What happens if x equals to 1? The plot doesn't show it. What happens when x equals to 1?
Infinity, Doctor.
Okay.
Undefined.
It's undefined. It looks infinity. Okay. Macam ni when you can write this down in your notes. When think about the number 0 and the number infinity, something like this. Think about the number infinity. Infinity is not really a number. Infinity is a concept that it's larger than anything. That means you think about all the numbers you can think of. All that numbers you can think of. Infinity is larger than that. Okay, you are never going to reach infinity. The same thing with 0. Okay, 0 is a number, but one good way of thinking about 0 is a really, really, really small number. Think about it like that. Okay, so for example, this plot is interesting. When x equal to 1, what will happen is 1 over 1 minus 1, which you will think as 0. So 1 over 0 is undefined, of course. But if you think about 1 over a really, really, really small number, you are going to get a really, really, really big number. Am I correct? Okay. 1 over a super small number, you are going to get the answer will be a super big number. So this is what happened there. When 1 minus 1, because in calculus you need to think about limit. When x is approaching 1, this down here, the term down here will get close to 0. 1 over that. So this graph here will continue to, it will try to reach infinity. Okay, let me see if I can do this. Plot, what was the 1 over 1x minus 1? Have you heard of the word asymptote? Asymptote.
Yes.
Yeah, okay. So asymptote is something that I really, this is the, when you talk about functions like this, I need to talk to you about asymptotes. It's why doesn't it plot the asymptote as well? It's not plotting it. Let me see if I can do it here. Plot asymptotes 1 over x minus 1. I hope it plots the asymptote as well. Okay, nice. It does that. So if you plot this function right here, 1 over x minus 1, it's going to show you two asymptotes. This one is called the vertical asymptote. Asymptotes means this graph will never reach this. It will never touch this asymptote. This is just the limit where it's gonna go. It's just an imaginary, well, I don't want to use imaginary, but it's just a virtual line to show you where these plots will going to approach. So these plots, if you get closer and closer to 1, closer and closer to 1, it's going to approach this virtual line here. It's going to approach this vertical asymptote. As x from here approaching to closer to 1, is going to approach this. But it's never, the plot is never going to touch that. Okay? And then there's another asymptote, horizontal asymptote. Okay? As y direction goes to 0, it will approach 0. So there's another asymptote here. You see? So the value of y, the range, it will not reach this line right here. Okay, so that's why here the function 1 over x minus 1 will approach 0. Okay, this is how you read it. The function 1 over x minus 1 will approach 0 as x approach minus or negative infinity. Negative infinity is being that direction and that direction. Okay. Okay. And also that function will approach infinity as x approaching 1. So as x approach 1, x cannot be 1, yeah? X cannot be 1 because at x equals to 1, the function is undefined. So we can always say, can say x approach 1. So this is really interesting. I need to show you another weird asymptote. Let me see if I can get this here. Plot asymptote x minus 3 times x plus 2. This is going to be weird. The asymptote is not vertical, it's not horizontal. I hope I can show it here. Let's move from alpha, do some. Yeah, here we go. Here we go. You look at this. There's, okay, vertical asymptote is easy, you know. The function will go to infinity. Yeah, y will go to infinity as x is approaching minus 1. There's minus 1 right there. But there's another, what we call oblique asymptote. Okay. These two functions will not reach this line here, this oblique asymptote. Asymptotic at x minus 2. So if you plot this x minus 2 line, plot x minus 2, the function here will not reach that. So in this function right here, in this function, x minus 3 times x plus 2 over x plus 1, it will never reach this asymptote. Okay.